So, dear students, continuing with our topic of chirality, optical activity, asymmetric carbons or stereocenters. So far, we have discussed uh, what are chiral and achiral molecules or objects. So I said that a chiral object, a chiral object or a chiral molecule has a non-superimposable mirror image, has a non-superimposable mirror image, has a non-superimposable mirror image, while as an achiral molecule, well as an achiral molecule has a superimposable has a superimposable mirror image. I gave you examples of a hand and a chair, and I said that a hand a hand it has non-superimposable mirror image, so we call it's chiral. Chair has superimposable mirror image, so we call it as achiral. We'll limit our discussion to molecules. So I will give you some examples to further make this topic understand to you people, so that you can understand it well. Let me give you some examples. uh, Here are some of the molecules. These are the 3D models of different molecules, and you can see there are different molecules: 1, 2, 3, 4, 5, and 6. Starting with this, if you see this molecule here, uh, it has a central atom, it has a central carbon, and it has 4 groups, but these 4 groups are identical groups. So in no way this molecule can be chiral. It will always be achiral, so leave it. Moving to second one, this one, it has this central carbon. These white balls, they represent hydrogen mostly. They represent hydrogen. This carbon is attached to 3 hydrogens here, 3 hydrogens and another group. It can be any group. So 3 hydrogens are there, they are identical, so no question of chirality for this molecule. Moving to carbon number 3, compound number 3. Here you have 2 hydrogens here, one here, and these 2 groups means it has 2 types of groups. One type is this is one type of group, and this green are second type of group. But still, this central carbon, it's not attached to 4 different groups, it's attached to 2 different groups. So no question of, so it's achiral, this one is achiral, this one is achiral. Moving on to this one, now we have how many different types of groups here? We have, this is one type, 2, and 3. Means this central carbon is still not attached to 4 different groups. It's attached to 4 groups. This carbon is attached to 4 groups, but 2 of those groups, these green balls, they are identical. So the central carbon here, the central carbon is attached to three different groups, 1, 2 and 3. So it's still a chiral. It's still a chiral. Moving on to compound number 5. What about this? This carbon, central carbon, it's attached to 1, 2, 3, 4. Now we have the required, the required criteria for chirality is present in this molecule, because the central carbon is attached to 4 different groups, 1, 2, 3 and 4. So such a molecule will be chiral. And look at this, what is this? Is it the same molecule or a different molecule? These two molecules, they are mirror images. They are mirror image. But what kind of mirror images are they? They are non-superimposable mirror images. We'll call them as, they are non-superimposable mirror images. So such molecules we call as chiral molecules. So they will be chiral. Moving on to another term that we use, and that term is asymmetric carbon. What is an asymmetric carbon? It's the same thing. Chiral carbon or asymmetric carbon. We define an asymmetric carbon. An asymmetric carbon is a carbon atom or asymmetric center. It's not necessary that it has to be carbon. You can call it, general term is asymmetric center. An asymmetric carbon or an asymmetric center is an atom that is attached to four different groups. That is attached to four different groups or atoms. It's known as an asymmetric carbon. Or an asymmetric carbon is also known as a chirality center. It's also called as a chirality center or a chiral center. You know it. We have explained this thing so far. Now